Okay, so now let's continue with combinations. Okay, so just like we have permutations, we have another counting technique which is known as the combination. Okay, so let's look at that. So a combination is a selection of a number of objects when the number of arrangements is not what's important. Okay, that's what combination is. Permutation, on the other hand, considers the order of what arrangement. Okay, but in this case, the order of what arrangement is not what considered. Okay, so I used an example in the permutation video where I said, for example, we have four students. Okay, where you have student A, student B, student C, and then student D. Okay, and then let's say you want to select two of these students, okay, out of the four to play a tennis game. Okay, and then a tennis game involves two people. So what will happen is that we are going to look at the possible combination that we can do to get two students out of the four to play the game. Okay, so at first we can have A and B, students A and B playing. We can have students A and C playing, or we can have students A and D playing. Also, we can have students B and C playing. We can have students B and D playing, and also we can have students C and D playing. So in this case, you see that whether I choose student A first or I choose student B first, and then I've chosen two of them to play the tennis. Okay, the order doesn't matter here. Whether let's say I have Kofi and Amma, and then they are to play a tennis ball. Whether I chose Kofi first or I chose Amma first to play the ball, it doesn't really affect anything. So in this case, the order is not the order is not considered. All you have to do is to make sure that you've gotten possible combinations. Okay, so that's what combination is about. Okay, so let's look at another case of combinations, which is known as the combination of subsets, which says that the number of combinations of a set of n objects taking R at a time is taking R at a time, or the selection of R objects out of n is written as NCR or NR, where NCR equals n factorial over R factorial multiplying n minus R factorial. So this is another case where let's say we have n objects, okay, and then we are supposed to choose R out of what the n objects, okay. So in this case, we are just going to look at the possible number of what selections that we can do, okay, from the total n object that we have, okay. So we have n objects, and then we asked to choose R objects out of what the n, okay. In this case, order doesn't matter, okay. So if you have such a situation, then you can use what this formula here, okay, where R is equal to the number of objects that you are selecting out of what the total number of objects available. So that's what combination of subsets also means. So let's take these examples that I have here. The first example says that in how many ways can a football team be selected from a class of 20 students? In how many ways can a football team be selected from a class of 20 students? So let's look at how you are going to answer this question. Okay, so you know that in a football team, we need 11 people to play, right? So our R will be equal to 11, and then we have a total of 20 students available. So our N is equal to what? 20. So in this case, what is happening is that you want to get a football team from what these 20 students, okay? And then you are being asked that how many ways can a football team be selected from what the 20 students, okay? And then you know that in this case, okay, if there are 11 players, okay, whether I choose the keeper first before I choose the striker, I say that in this case it doesn't matter, okay? So in this case the order doesn't matter, who I will choose first doesn't matter. All you are concerned is about getting looking at the number of possible ways that you can get the 11 players out of what the 20 that is what available to form the football team. So in this case, you're going to have NCR, which will be equal to 20 combination R, which is what 11. Okay, and then this will be equal to 20 factorial, okay, divided by r factorial, which will be 11 factorial, right? Multiplying 20 minus 11 factorial, right? So let's see what you're going to get. So you're going to have 20 factorial divided by 11 factorial, multiplying 20 minus 11 factorial, okay? This will give us a value of 167960 different ways, okay? So these are the number of possible ways where order is not considered, okay, that we can select a football team from the class of 20 students. So let's look at the second question also. The second question says, in how many ways can 4 boys be chosen out of what? 6 boys. Okay, in how many ways can 4 boys be chosen out of what? 6 boys. So in this case, we've not really been given the aim, the purpose or the reason behind 4 boys being chosen out of what? The 6 boys. So you can see that order doesn't matter because we don't really know the reason. Maybe, for example, if we know what the 4 boys are going to do, then we can decide whether the order is going to matter or the order doesn't matter. But in this case, I assume it's combination that it hasn't been specified. You are going to consider, you're going to see that the order doesn't matter in this case. So in this case, we have 4 boys. That means that n is going to be, sorry, have 6 boys. That means that n is going to be 6. And then we want to choose 4 out of the 6. So r will be equal to what? 4. So I want to find the number of possible ways that you can choose these 4 students out of the 6 without repetition. So let's look at that. That will be 6 combination 4. That's going to be 6 factorial divided by 4 factorial, multiplying 6 minus what? 4 factorial. 6 minus 4 factorial. So let's see what you're going to get for this also. So you have 6 factorial divided by 4 factorial, multiplying 6 minus 4 factorial. Okay, this will give us a value of what? 15 possible ways. So we can say we have 15 possible ways to select 4 boys out of what? The 6 boys. So let's look at the last question, which says that in how many ways can 3 equal prizes be given to 5 boys? In how many ways can 3 equal prizes be given to what? 5 boys. So in this case, the prizes are equal, okay? So it doesn't matter the one that you give to any of the boys, okay? Since the prizes are equal. Should this be that the prizes are different, then the order is going to matter in this case. But in this case, the prices are what? Equal, okay? So let's say if you have from first position to uh, the fifth position, and then we have different prices for each one of them, depending on how high you are, then we can't go and give the price for the first person to the fifth person, right? So that means that what the order in this case what matters. So that, sorry, the order, yeah, in that case, it matters because you can't give the price for the first person to the fifth person since the prices are different. But in this case, that the prices are all equal, that means that what the order does not what matter. Whether I give one price to the first or I give it to the third person, it doesn't matter because at the end they're all getting the same price. So in this case, our R will be equal to 3, and then we have 5 boys. So our N will be equal to what? 5. We're going to have 5 combination 3. That's going to give us 5 factorial divided by 3 factorial, multiplying 5 minus 3 factorial. Okay, so let's see what you're going to get for this. So we have 5 factorial, okay, divided by 3 factorial, bracket open, 5 minus 3 factorial. That's what you're going to get for that. So that'll give us a value of what? 10. So you have 10 different ways, okay, to give the 3 equal prizes to what? The 5 boys. Okay, so that's all for this lesson.